Imagine standing high in the remote Bolivian highlands, where the air is so thin your lungs ache with each breath, and the endless horizon stretches across a barren plateau. The sun beats down intensely, its rays unfiltered by the thin atmosphere, casting long shadows over the ground. No trees grow here, just rocks, and the wind carries whispers of something ancient, an enigma that has baffled archaeologists, engineers, and curious minds for centuries. This place is called Puma Punku, and it sits nearly 13,000 feet above sea level, higher than many commercial aircraft fly. The name Puma Punku is derived from the Amara language, meaning the door of the puma, and its significance has only deepened with time. It is a place that defies explanation. The stones scattered across this wind-swept plateau are not mere boulders, they are massive blocks, some weighing over 100 tons, strewn about as though left by a giant child bored of playing with blocks. But these are not rough-hewn, irregular rocks. These are precision-cut monuments, each one a testament to an ancient craftsmanship beyond anything that should have been possible. The edges of these stones are sharp, their surfaces smooth, and the angles perfect 90-degree corners. Some joints between the stones are so tight that even a razor blade cannot slip through them. Think about that for a moment. No mortar, no adhesive, just stone against stone, fitted with such exactness that even the thinnest sheet of paper can't pass between them. This is not the work of crude tools and primitive labor as we might imagine it. This is something else entirely. Mainstream archaeology tells us that Puma Punku was built by the Tiwanaku civilization sometime around 500 to 600 AD. This was a sophisticated culture. Indeed, one that developed advanced agricultural techniques and dominated the Andean region for centuries before the rise of the Inca. They had no written language, no knowledge of the wheel, and their toolkit, according to conventional scholarship, consisted of stone hammers, copper chisels, and perhaps some bronze implements. And yet, with these primitive tools, they allegedly carved andite and red sandstone with tolerances that modern engineers still struggle to replicate. The stone itself is hard, far harder than the copper tools they were supposed to be using, with a mineral hardness scale ranging from 1 for talc to 10 for diamond. Puma Punku's stones register around 7. Copper, by comparison, sits at a mere 3, and bronze might reach 4. The mathematics simply does not add up. You cannot carve a material that is nearly twice as hard as your cutting tool. Yet, there it is, evidence scattered across the Bolivian Altiplano, defying all logical explanations. Let's examine the stonework more closely. Among the most famous features of Puma Punku are the H-shaped blocks. These are not simple rectangular stones. They are complex, three-dimensional puzzles, carved with recesses, grooves, and protrusions that interlock with neighboring blocks in multiple directions. Each H-block matches its counterparts with extreme precision. The notches align, the angles correspond, and the surfaces meet flush. It's as if these stones were manufactured to a standardized template, produced in some ancient factory with quality control measures that would satisfy modern industrial specifications. Think about what this implies. Standardization requires measurement, planning, and the ability to reproduce identical results across multiple units. Today, we achieve this through computer-aided design, precision machining, and rigorous quality assurance protocols. The Tiwanaku people supposedly achieved it with rocks and sticks. The cognitive dissonance here is staggering, but the H-blocks are only part of the mystery. Perhaps more troubling are the drill holes scattered throughout Puma Punku. Small, perfectly round perforations are bored into the hardest stone with mechanical uniformity. These holes are typically 6 millimeters in diameter, spaced at identical intervals along carved grooves. The walls of these holes are smooth, and the depths are consistent, with no wandering marks, no signs of human error. These holes appear to have been made by something rotating at high speed with unwavering stability. In one particularly famous stone, a perfect groove runs along a carved surface, lined with these 6 mm holes drilled at precise intervals along its length. Engineers who have examined this stone note that recreating such work today would require diamond-tipped drill bits and power tools. The idea that this was accomplished with a bow drill and copper tubing strains credulity to its breaking point. Then there's the issue of transportation. The largest stones at Puma Punku weigh over 130 tons. The red sandstone blocks were quarried from a site about 10 kilometers away near the shores of Lake Titicaca. The anderite blocks came from even farther, from quarries on the Copacabana Peninsula, 90 kilometers distant across the lake. Moving a 130-ton stone 10 kilometers is not a trivial undertaking. Moving it up a steep incline to an elevation of nearly 13,000 feet is something else entirely. Remember, there are no trees at this altitude. The natural tree line falls well below Puma Punku, meaning the builders could not have used wooden rollers. A standard explanation for how ancient people moved massive stones. No trees mean no logs. No logs mean no rollers. And without rollers, how do you move something that weighs as much as a modern locomotive? The Inca, who came later and incorporated Puma Punku into their own mythology, denied building it. When the Spanish conquistadors arrived and asked the indigenous people about the origins of these ruins, they were told that the structures had been built by the gods themselves in a single night, long before human memory. The stones, they said, were moved through the air by the sound of a trumpet. Take that as you will. Dismiss it as primitive superstition if you prefer. But consider that legends often preserve fragments of truth wrapped in metaphor. What technology might have seemed like magic to later observers? What process might have looked like stones floating through the air to people who had no framework for understanding it? The destruction of Puma Punku itself presents another puzzle. The site today is a ruin, scattered blocks, broken monuments, and displaced megaliths. Something catastrophic happened here. The stones are not merely weathered by time. They appear to have been violently disrupted, tossed about by forces powerful enough to move objects weighing dozens of tons. Some researchers point to earthquakes. Others suggest flooding from Lake Titicaca. A few propose more exotic explanations, such as ancient conflicts or deliberate demolition by unknown parties. The questions remain unanswered. But the stones tell a story of a civilization far beyond what we understand today. A story that forces us to ask, what did our ancestors know that we have forgotten? The stones remember, and they are ready to tell us. Whatever destroyed Puma Punku did so with a force that makes it nearly impossible to reconstruct the original layout. Unlike the nearby ruins of Tiwanaku, where walls still stand and structures retain their basic form, Puma Punku is chaos frozen in stone. It's as though someone took a completed jigsaw puzzle and hurled it against a wall. Pieces remain, but the picture they once formed is lost. Researchers have attempted to digitally reconstruct what Puma Punku might have looked like in its prime, using 3D scanning technology and computer modeling. They have tried to fit the scattered blocks back together into coherent structures, and the results suggest a terrace platform mound with multiple levels, elaborate gateways, and precisely aligned astronomical features. However, these reconstructions are speculative. The cataclysm that reduced Puma Punku to rubble remains a mystery. But what we do know is that the precision of its construction still endures. Even in its broken and scattered state, the stones of Puma Punku testify to capabilities we cannot yet explain. Take the drill holes. For example, they remain perfectly cylindrical after 500 years or more. The H-blocks still interlock with their neighbors as if they were machined yesterday. The surfaces are smooth, the angles true, and the mystery remains unsolved. Some have proposed that the stones were not carved but rather cast a theory known as the geopolymer hypothesis. This suggests that ancient builders created a kind of concrete, mixing Freud-Crusite rock with chemical binders, pouring the mixture into molds to create blocks that appear to be natural stone, but are actually synthetic. Proponents of this theory point to the perfect fits between blocks, arguing that casting could explain how stones could be made to match so precisely. If wet concrete is poured against an already hardened block, the new material would conform exactly to its neighbor as it sets. This idea has some scientific backing. A peer-reviewed study published in Materials Letters found evidence consistent with a geopolymer matrix binding natural sandstone grains together. The researchers identified chemical signatures suggesting that alkaline salts from a nearby salt flat may have been used as a binding agent. If true, this would be a remarkable ancient technology recently rediscovered. However, the geopolymer theory does not explain everything. It doesn't account for the andesite blocks, which show no signs of having been cast. It doesn't explain the drill holes, which would be unnecessary if the stones were molded. And it doesn't solve the transportation problem moving such massive stones, even if they were cast, would still require immense effort. Perhaps the truth involves a combination of techniques. Maybe the Tiwanaku used casting for some elements and carving for others. Or perhaps they possessed knowledge that combined chemistry and engineering in ways we haven't yet imagined. There's also the possibility that they inherited their skills from an even older civilization, one whose memory has been erased by time and catastrophe. The conventional archaeological timeline places the construction of Puma Punku around 500 years ago, but some researchers suggest it may be much older, potentially dating back to the end of the last ice age around 12,000 years ago. If true, this would place Puma Punku among the oldest monumental structures on Earth, potentially even contemporaneous with, or predating, Göbekli Tepe in Turkey. The implications of such a revised chronology are profound. It would suggest that advanced stoneworking techniques existed thousands of years earlier than currently believed, implying that a sophisticated civilization flourished and then vanished, leaving only these scattered ruins as evidence. This would force us to reconsider the entire story of human technological development. For now, Puma Punku keeps its secrets. The stones remain silent. The drill holes offer no testimony. The H-blocks interlock in patterns whose meaning we can only guess at. But if you listen closely, standing on that windswept plateau, letting the thin air carry your thoughts beyond the boundaries of conventional wisdom, you might hear something. Not answers, perhaps, but questions. Questions that echo across millennia, urging us to consider possibilities we have long been taught to dismiss. And these questions do not stop at the borders of Bolivia. They travel north along the spine of the Andes to another site, where equally impossible stones guard another inexplicable mystery. Welcome to Sacsayhuaman, a fortress overlooking the ancient Inca capital of Cusco, Peru. Here, the most stunning example of megalithic construction in all of the Americas awaits. The fortress rises from the hillside like the spine of a colossal buried creature, with 3 massive terraces zigzagging across the landscape in a pattern that seems almost ceremonial, almost beyond human comprehension. The name Sacsayhuaman itself carries mystery. Some translate it as the satisfied falcon, a reference to the bird that once guarded the skies above this sacred site. Others interpret it as speckled head or city of stone. The Quechua language allows for multiple meanings, and perhaps all of them apply. What cannot be disputed, however, is what your eyes will tell you when you stand before these walls. Something extraordinary happened here. Something that challenges everything we think we know about the capabilities of ancient peoples. The numbers alone are staggering. The 3 parallel walls stretch for approximately 400 meters, rising in stepped terraces that reach nearly 20 meters in height. The stones that make up these walls are not uniform blocks quarried to standard dimensions. They are enormous, irregularly shaped boulders, some weighing over 200 tons, fitted together with such precision that the joints between them remain invisible to anything thicker than a human hair. No mortar binds them. No cement fills the gaps. There are no gaps to fill. Walk up to one of these walls and run your hand along the surface. and you will feel the stones meeting in perfect continuity. The ancient builders did not merely stack rocks, they sculpted them. Each boulder was shaped to interlock with its neighbors in 3 dimensions, creating a structure that resembles a giant jigsaw puzzle made of granite. Some individual stones display 12 or more angles on their visible face alone. Below the surface, where they contact adjacent blocks, the complexity only increases. Consider the engineering challenge this represents. To fit 2 flat surfaces together is relatively simple, but to fit 2 curved or angled surfaces together requires more skill. Fitting a stone with 12 different angles against multiple neighboring stones, each with their own complex geometries, while maintaining tolerances so tight that not even a blade of grass can penetrate the seams, that is a level of precision that defies explanation. Modern architects and engineers who have studied Sacsayhuaman openly admit that replicating this work today would be extraordinarily difficult, even with contemporary tools and technology. The Inca Empire, which mainstream archaeology credits with building Sacsayhuaman, flourished from the early 13th century until the Spanish conquest in the 1532. But the skills required to build such a marvel are beyond the capabilities we attribute to them, and the mystery only deepens when we consider the ancient legends that have been passed down for centuries. Could these advanced techniques have come from an even older civilization, one that predated the Inca and whose story has been erased by time and disaster? Sacsayhuaman, much like Pumapunku, raises more questions than answers. The incredible precision of the stonework, the sheer scale of the construction, and the mysteries of transportation and techniques all point to something far beyond our current understanding. The more we uncover, the more we realize that there are gaps in our historical narrative that no amount of conventional archaeology can fill. We are left to wonder what other secrets these stones might hold, and whether the answers lie buried beneath the earth, waiting to be uncovered. At its peak, the Inca Empire spanned from present-day Colombia to Chile, covering vast territories and countless people, connected by thousands of kilometers of meticulously constructed roads. The Inca were undoubtedly master builders. Their agricultural terraces are still functional today. Their road system rivals that of ancient Rome, and their suspension bridges, some of the most impressive feats of engineering in history, spanned chasms that would challenge even modern engineers. However, the Inca had no iron, no steel. Their hardest metal was bronze, an alloy of copper and tin, which registers only about 4 on the Mohs hardness scale. Meanwhile, the stones used at Sacsayhuaman are primarily limestone and andesite, materials ranging from 3 to 7 on the same scale. Bronze tools could theoretically work limestone, but it would take tremendous effort, and the precision achieved here goes far beyond what mere brute force and patience can explain. Mainstream explanations suggest that the Inca shaped these stones using a process called pecking. Workers would strike the surface of a boulder repeatedly with harder stones, gradually wearing it down until the desired shape emerged. Then, these stones would be lifted into place using ramps, levers, and a labor force of hundreds or even thousands of workers to achieve the precise fit between blocks. Workers would have placed stones adjacent to one another and ground them together with sand and smaller rocks as abrasives, slowly wearing away the contact surfaces until they matched perfectly. This explanation is plausible, and is even supported by Spanish chronicles from the Conquest era, which describe seeing large work crews engaged in construction projects. But plausibility alone doesn't equate to proof. Several aspects of Sacsayhuaman defy this conventional narrative. First, consider the time it would take. Grinding 2 irregular stone surfaces together until they match perfectly would require an immense amount of labor. Multiply this by the thousands of joints at Sacsayhuaman. Add the time needed to quarry, transport, and lift stones weighing up to 200 tons, and you have a construction timeline that strains credulity. Some estimates suggest the fortress took 60 years to build with a workforce of 20,000 men. Yet even this massive mobilization of labor could not account for the precision achieved. Second, consider the absence of tool marks. When you shape stone by pecking or grinding, you leave evidence of your work. The surface retains traces of the impacts and abrasions that formed it, but many of the stones at Sacsayhuaman have remarkably smooth, almost polished surfaces, with no visible indication of how they were worked. It's as if the material was shaped by some process that left no signature, or by tools so refined that their marks are invisible to the naked eye. Third, we come to the concept of vitrification, a mystery that deepens the puzzle considerably. Vitrification is the process where a material is transformed into glass by the application of extreme heat. When stone is heated to temperatures exceeding 1,100 degrees Celsius, its surface can melt and solidify into a glassy, polished finish. Researchers examining certain stones at Sacsayhuaman have noted that their surfaces appear vitrified, suggesting they were exposed to temperatures far beyond what any conventional construction technique could produce. The Inca had no furnaces capable of reaching 1,100 degrees Celsius, nor did they possess fuel sources that could sustain such high temperatures over large surface areas. And yet, the evidence of vitrification remains, a silent testimony to processes we cannot explain. Some researchers have proposed alternative theories. One such theory suggests that the ancient builders knew of a plant whose juices could soften stone, making it malleable like clay before hardening it into its final form. This theory isn't as far-fetched as it might sound. Early colonial chroniclers reported hearing stories of indigenous people using a plant to soften rock for construction. Even more intriguing, certain birds in the Andes appear to achieve something similar, excavating nesting cavities in solid rock faces, which local tradition claims is done by applying a mixture of plant material and saliva. Could ancient humans have observed this phenomenon and adapted the technique for architectural purposes? If such a stone-softening substance existed, it would explain many of the mysteries at Sacsayhuaman. The blocks could have been shaped with minimal effort while malleable, then pressed against neighboring stones to achieve perfect fits. The lack of tool marks would make sense because no conventional tools would have been needed, and the vitrified surfaces might result from a chemical reaction during the hardening process. But this theory remains unproven. No one has identified the plant in question, or demonstrated that its extracts can soften stone. Another theory suggests that Sacsayhuaman was not built by the Inca, but by an even older civilization, whose works the Inca simply inherited and maintained. Some researchers point to evidence suggesting that the site was occupied long before the Inca Empire arose, with construction phases dating back to the Quilqué culture, which flourished in the region around 1100 AD, some 3 centuries before the Inca consolidated power. But if the Quilqué built these megalithic walls, the mystery only deepens. The Quilqué were less technologically advanced than the Inca, not more. How could a less sophisticated culture have accomplished what their more advanced successors could not, unless, of course, the true builders were a civilization so ancient that even the Quilqué found their works already standing when they arrived? This leads to the hypothesis of a lost predecessor civilization, one that possessed advanced knowledge and capabilities, subsequently lost to history. Graham Hancock and other alternative researchers have popularized this idea, suggesting that a global catastrophe at the end of the last ice age, about 12,000 years ago, destroyed an advanced culture and scattered its survivors across the world. According to this theory, these survivors became the teachers and civilizers remembered in myths from every continent, passing on fragments of their knowledge to the indigenous peoples they encountered. The Inca themselves may have preserved a memory of these ancient builders. Their origin myths describe a creator god named Viracocha, who emerged from Lake Titicaca and traveled across the land teaching the arts of civilization before departing across the Pacific Ocean. Viracocha was described as tall, bearded, and light-skinned, characteristics that do not match the indigenous population. Was Viracocha a mythologized memory of contact with an unknown people who brought advanced knowledge to the region? The Spanish conquistadors found these stories sufficiently intriguing to record them in detail. They also noted the indigenous insistence that certain ancient structures, including Sacsayhuaman, predated the Inca and had been built by a vanished race. Could the builders of Sacsayhuaman be the survivors of a lost advanced civilization? The Inca took credit for many monumental feats, but they never claimed to have built the massive, megalithic walls of Sacsayhuaman. According to their own tradition, these walls had always been there, long before the time of memory. Standing at Sacsayhuaman today, gazing down over the terracotta rooftops of Cusco spread below, it's easy to understand why this place inspired awe. The walls are simply too massive, too precise, and too perfectly fitted to fit into easy explanations. Despite centuries of earthquakes that have devastated the colonial buildings below, these ancient Inca walls stand unchanged. The Spanish churches and palaces, built with advanced European techniques, have crumbled and been rebuilt multiple times. But the Inca walls, or whoever truly built them, remain perfectly intact. This seismic resilience is itself a testament to sophisticated engineering. The walls lean slightly inward, designed in such a way that their interlocking, irregular shapes distribute stress across multiple contact points rather than concentrating it at single joints. The entire structure flexes and settles during earthquakes, rather than cracking and collapsing. Whether by intention or intuition, the builders of Sacsayhuaman created walls that work with nature's forces, not against them. Some even propose that the site was designed to harness earth energies in ways we don't yet fully understand. The layout of Sacsayhuaman is said to resemble the head of a puma when viewed from above, with Cusco itself forming the body of this sacred animal. The puma, deeply intertwined with Andean cosmology, represented the earthly realm and physical power. By shaping their capital in this form, the Inca expressed their spiritual connection with the land. But spiritual symbolism doesn't explain construction technique. Whatever metaphysical significance the puma may have held, the builders still had to move 200-ton stones up the mountainside and fit them together with superhuman precision. The metaphysics of puma symbolism offers no answers to the physics of megalithic engineering. Perhaps the most honest response to Sacsayhuaman is to admit what we don't know. We don't know exactly how the stones were cut. We don't know how they were transported. We don't know how they were fitted together with such impossible accuracy. We have theories, some more plausible than others, but none that fully explain the marvels that stand before us. And what stands before us is nothing short of humbling. It reminds us that our ancestors were capable of feats we still struggle to comprehend, let alone replicate. It suggests that knowledge can be lost as much as it can be gained, that civilizations can decline just as much as they can advance, and that the arrow of progress doesn't always move forward. The satisfied falcon of Sacsayhuaman guards mysteries that may never be fully solved. But the questions it raises go far beyond the Andes. They travel across oceans and continents to other ancient sites where similar impossibilities await explanation. Sites where granite was drilled with precision that defies primitive tools, where massive stones were hollowed out to tolerances measured in thousandths of an inch, where the evidence of lost technology is etched into the hardest materials on Earth. In a small museum at University College London, housed in a modest display case that most visitors walk past without a second glance, there sits an object that should be impossible. It's a cylinder of rose granite, roughly the size of a drinking glass, with a hollow center and spiral grooves running along its surface. This unassuming artifact is known as Core 7, and it represents one of the most profound challenges to our understanding of ancient Egyptian technology. Core 7 is a drill core. When you drill a hole using a tubular bit, the center of the material being drilled remains intact, forming a cylindrical plug that can be removed once the hole is complete. This is basic engineering, something any modern machinist understands. But what makes Core 7 extraordinary is not what it is, but how it was made. Sir, William Flinders Petrie, one of the founding fathers of modern Egyptology, discovered core 7 and others like it during his excavations in Egypt in the 1880 seconds. Petrie was a meticulous observer, and what he saw on these cores troubled him deeply. The spiral grooves weren't random scratches, they were uniform, consistent, and they told a story that contradicted everything Petrie thought he knew about ancient Egyptian capabilities. By measuring the spacing between the grooves, Petrie calculated the feed rate of the drill that had created them. Feed rate refers to how quickly a drill advances into the material being cut with each rotation. Modern industrial drills operating on granite typically achieve feed rates of about 20 thousandths of an inch per revolution. But the ancient Egyptian drill that created core 7, according to Petrie's measurements, achieved a feed rate of 1/10 of an inch per revolution. This is 50 times faster than modern diamond tip drills operating at 900 revolutions per minute. Let that sink in for a moment. An ancient civilization, supposedly equipped only with copper tools and sand abrasives, was drilling granite 50 times more efficiently than we can with modern machinery. Either our understanding of ancient Egyptian technology is fundamentally wrong, or the laws of physics worked differently. 4,000 years ago. Neither option is comfortable. Christopher Dunn, a manufacturing engineer with over 50 years of experience in aerospace precision machining, has spent decades examining Egyptian artifacts through the lens of modern engineering, and his conclusions are deeply unsettling to mainstream Egyptology. Dunn has personally handled core 7 and other drill cores in the Petrie Museum, and he confirms that the characteristics Petrie observed are genuine. The spiral grooves are there. The feed rate calculations are mathematically sound, and the implications are revolutionary. The conventional explanation for Egyptian drilling involves a copper tube, sand as an abrasive, and a bow mechanism to provide rotation. Workers would pour sand into the hole, insert the copper tube, and rotate it back and forth using a bow. Similar to starting a fire with a spindle, the sand would grind against the granite, slowly wearing it away, while the copper tube served as a guide. It's a plausible theory, and experiments have shown that this method can produce holes in granite, though extremely slowly. But it cannot produce core 7. The problem isn't just speed, but the physics of abrasive cutting. When you grind material away using loose sand, the cutting action is random. Sand particles tumble and roll between the tool and the workpiece, removing material in all directions without any consistent pattern. This process does not create the clean, uniform spiral grooves visible on the Egyptian cores. Those grooves indicate that something was cutting continuously, following a helical path through the granite, removing material in a controlled and predictable manner. Some researchers have proposed that the Egyptians used fixed-point cutting, where abrasive particles are embedded in or attached to the drill bit, rather than floating freely. This is how modern diamond drill bits work. Tiny industrial diamonds are bonded to the metal surface of the bit, and as the bit rotates, these fixed cutting points carve through the material with precision. Fixed-point cutting could theoretically produce spiral grooves, but it requires abrasives harder than the material being cut, which, in the case of granite, means something at least as hard as quartz, ideally diamond itself. Did the ancient Egyptians have access to industrial diamonds? The conventional answer is no. While diamonds were known in antiquity, they were viewed as precious gems, not tools for industrial use. The idea that the Egyptians would have used diamonds for mundane drilling tasks, wearing them down and discarding them by the thousands, seems economically and culturally implausible. Yet, the evidence on core 7 suggests that some form of fixed-point cutting was employed. There is, however, another possibility, one that ventures into more exotic territory. Christopher Dunn, a manufacturing engineer, has proposed that the ancient Egyptians may have used ultrasonic drilling. Ultrasonic machining involves vibrating a tool at frequencies between 19,000 and 25. 0.000 cycles per second. Far beyond the range of human hearing, these high-frequency vibrations cause an abrasive slurry to chip away at the material in a controlled manner. This technique is particularly effective on hard, brittle materials like granite. Interestingly, granite contains quartz crystals, and quartz exhibits a property called piezoelectricity. When mechanical pressure is applied to quartz, it generates an electrical charge. Conversely, when an electrical charge is applied to quartz, it vibrates at a specific frequency. This property is why quartz crystals are used in modern clocks and electronic devices. Dunn suggests that if the Egyptians understood piezoelectricity, they could have developed ultrasonic tools that would cut granite with unusual efficiency, leaving the distinctive marks visible on their drill cores, though speculative. This hypothesis challenges conventional Egyptology, which dismisses it as fantasy. Mainstream Egyptology has yet to produce a satisfactory explanation for Core 7. The artifact sits in its display case, quietly defying the official narrative, waiting for someone to solve its riddle. But the drill cores are not the only evidence of advanced machining in ancient Egypt. Beneath the desert sands at Saqqara, there lies one of the most enigmatic sites in all of archaeology, the Serapeum. This underground complex of tunnels, carved from solid limestone bedrock, extends for hundreds of meters beneath the surface. Inside these tunnels, nestled in niches along the walls, sit 24 massive granite boxes. These are not sarcophagi in the conventional sense. Although they are often described that way, they are precision-engineered containers, carved from single blocks of Aswan granite, and finished to tolerances that defy belief. The boxes measure approximately 4 meters long, are 3 meters wide, and 3 meters tall, weighing between 70 and 100 tons each. The lids alone weigh 30 tons, and they were cut from the same blocks as the boxes themselves. When engineer Christopher Dunn examined these boxes with precision measuring instruments, he found that the interior surfaces were flat to within 0.00021 inches. The corners were square to within a few arc seconds. The parallelism between opposite faces was maintained across the entire interior surface. These are not rough-hewn containers. They are the products of advanced manufacturing, executed to standards that would satisfy a modern aerospace machine shop. Think about what it takes to achieve such precision. You need measuring instruments capable of detecting deviations smaller than the width of a human hair. You need cutting tools that can remove material in controlled increments without wandering or chattering. You need a stable work environment where vibrations and temperature changes do not affect your measurements. And you need the knowledge and skill to integrate all these elements into a coherent manufacturing process. The mainstream explanation claims that these boxes were created by workers using copper chisels and stone hammers, checking their progress with simple measuring tools like plumb bobs and string. According to this view, the precision was achieved through patient craftsmanship over many years, with workers gradually refining the surfaces until they met the required standards. This romantic notion of dedicated artisans lavishing decades of effort on each piece is compelling, but it doesn't account for the physical evidence. Copper chisels cannot cut granite. Granite is composed primarily of feldspar and quartz, both harder than copper. Strike a copper chisel against granite, and the chisel deforms while the granite remains unchanged. This is not speculative theory, it's basic material science, just as applicable today as it was 4,000 years ago. To shape granite, you need tools at least as hard as the material being cut. Yet, the ancient Egyptians had no such tools, and yet, there the boxes sit, deep in the darkness beneath Saqqara, their surfaces smooth and their angles true. In 1850, French archaeologist Auguste Mariette discovered the Serapeum and had to use explosives to open some of the boxes, as he could find no other way to lift the 30-ton lids. When he finally looked inside, he found them empty. No mummified bulls. Despite the official theory that the Serapeum was a burial place for sacred Apis cattle. No grave goods, no inscriptions, nothing to indicate what purpose these meticulously crafted containers originally served. Some of the boxes do bear hieroglyphic inscriptions on their exteriors, but these inscriptions are crudely scratched into the polished surfaces, clearly added long after the boxes were made. The contrast is striking. Whoever created the boxes possessed the technology to achieve optical flatness on granite. Whoever added the inscriptions could barely scratch recognizable symbols. It is as if two completely different civilizations, separated by vast gulfs of capability, interacted with the same objects at different points in time. This observation has led some researchers to propose that the boxes are far older than the Serapeum itself. Perhaps they were created by an earlier civilization and later repurposed by the dynastic Egyptians, who discovered them already in place and incorporated them into their own religious practices. The hieroglyphics would then represent the newer culture trying to claim ownership of artifacts they didn't create and could not replicate. Similar patterns appear throughout Egypt. At Giza, the valley temple adjacent to the Sphinx contains granite blocks fitted together with the same impossible precision seen at Sacsayhuaman in Peru. At Abu Rawash, drill holes penetrate basalt with spiral grooves identical to those on Core 7. At Abu Ghurab, alabaster basins display curves and hollows that would challenge modern sculptors. Everywhere you look, if you look with the eyes of an engineer rather than a historian, you find evidence of capabilities that should not exist. The Great Pyramid itself presents perhaps the greatest engineering mystery of all. Leave aside the questions of how 3 million blocks, averaging 5 tons each, were quarried, transported, and stacked to a height of nearly 150 meters. Focus instead on the precision of the finished product. The base of the Great Pyramid covers over 13 acres, and the maximum deviation from a perfect level across this entire area is less than 2 centimeters. The sides are aligned to true north with an accuracy of 3 arc minutes. Better than most modern structures achieve. The andesite enigma deepens as we examine the construction techniques of Pumapunku and other megalithic sites. Andesite, a volcanic rock formed when lava cools at intermediate rates, produces a denser, fine-grained stone of exceptional hardness on the Mohs scale of mineral hardness. Andesite registers between 6 and 7, making it one of the hardest construction materials used anywhere in the ancient world. For comparison, steel rates at about 6. A standard masonry drill bit struggles against andesite, and copper chisels would be utterly ineffective. According to mainstream archaeology, the Tiwanaku civilization supposedly worked this unforgiving material using stone hammers made from even harder rocks like diorite, combined with copper or bronze tools for finer work. The official explanation tells us that workers would have spent months, years, or even decades pounding and grinding their way through andesite, removing material bit by bit. But when you stand before the andesite blocks of Pumapunku, this official story starts to fall apart. Look closely at the cuts, they are not the rough, irregular surfaces you would expect from such a laborious process. The blocks are smooth, sometimes almost polished, with edges that remain sharp even after 1,500 years of exposure to the elements. The grooves are uniform in width and depth, and the angles are precise to fractions of a degree. The flat surfaces show no undulations, no tool marks, and no evidence of the brutal percussive process that was supposedly used to create them. Examine the interior corners. When carving a block of stone by hand, interior corners are notoriously difficult. The tool naturally wants to round the corner as it moves from one surface to another. Achieving a crisp 90 degrees intersection requires extraordinary care and precision. Yet at Pumapunku, some of the interior corners have radii as tight as 4 millimeters, about the diameter of a pencil lead. Modern engineers note that such tight radii would require specialized tools. Even today, tools specifically designed for confined spaces and maintaining precision at the limits of cutting technology. Christopher Dunn, An aerospace engineer who has studied ancient precision stonework for decades has observed that these Puma Punku corners are tighter than what modern cutting tools could achieve without difficulty. The ancient builders went far beyond what was necessary for aesthetics. A radius of 50 or 60 millimeters would have been perfectly acceptable to the human eye, but they chose 4 millimeters precision for its own sake. Or perhaps for a purpose we do not yet understand. The H blocks at Puma Punku deserve special mention. Each of these distinctive stones features a complex three-dimensional geometry, with recesses, protrusions, and channels designed to interlock with neighboring blocks. The consistency between the H blocks is nothing short of remarkable. They were clearly manufactured to a standardized template, with dimensions and angles that repeat from one block to the next, with minimal variation. Standardization implies measurement, quality control, and a production process that could reliably reproduce identical results. In modern manufacturing, we achieve this through precision measuring instruments, machining templates, and systematic quality assurance protocols. Yet, the Tiwanaku people supposedly achieved this with stone hammers and copper scrapers. The gap between method and result is staggering. Some researchers have even measured the H blocks and found that their dimensions appear to encode mathematical relationships. The proportions suggest familiarity with concepts like the golden ratio and other geometric constants. Whether this was intentional or coincidental, these relationships hint at a sophisticated understanding of mathematics that underpinned their construction program. The builders weren't just creating shapes that looked good, they were implementing designs based on abstract principles. The grooves on many Puma stones add another layer of mystery. These channels run along surfaces with remarkable uniformity, maintaining consistent width and depth along their entire length. Some grooves have non-parallel walls, flaring slightly from bottom to top in a profile known as a dovetail. Dovetail joints are common in woodworking and metalworking, where they provide exceptional resistance to pulling forces. But executing a dovetail in andesite using only the tools available to the Tiwanaku would have been extraordinarily difficult. The angles must be precise, the surfaces must be smooth, and the entire joint must maintain consistency over its full length. And then there are the metal clamps. At various points in the Puma Punku ruins, you can find recesses where metal staples once held adjacent blocks together. These staples were poured in place as molten metal, filling channels cut into the stone surfaces of both blocks, then solidifying to create a permanent bond. The technique is sophisticated, requiring knowledge of metallurgy, mold making, and the thermal properties of different materials. What makes this observation particularly intriguing is that identical clamp recesses appear at ancient sites thousands of miles away. The same technique was used at Delphi in Greece. The same technique appears in ancient Japanese construction. The same technique is found at sites across the Middle East. Either multiple civilizations independently invented the exact same method for joining megalithic stones, or they shared a common source of knowledge. This brings us back to the Andes. The mysteries of Puma, Punku, and Sacsayhuaman, the site in Peru, suggest that ancient civilizations had access to advanced engineering methods that are difficult to explain using conventional historical narratives. Whether it was a lost civilization or advanced knowledge passed down through time, the similarities in precision stonework across continents indicate that our ancestors may have possessed far more advanced technological capabilities than we currently recognize. The evidence of lost knowledge seems to lie scattered across the globe, from the pyramids in Egypt to the megalithic walls of the Andes and beyond. These questions continue to haunt modern archaeology. As we ponder how these ancient civilizations achieved such feats, we must ask ourselves, were they alone in their technological prowess? Or did a lost civilization leave behind a blueprint for advanced construction and machining that we have yet to fully understand? The distribution of advanced stoneworking techniques across ancient cultures raises profound questions about possible ancient cultural connections. Mainstream archaeology typically treats ancient civilizations as isolated, developing independently, each arising from local conditions and evolving through local innovations. The notion that distant cultures shared engineering knowledge implies contact and communication across vast distances, something the conventional narrative considers impossible for the time periods involved. However, what if the knowledge predates the civilizations we attribute it to? What if the Tiwanaku, much like the Greeks, Japanese, and the ancient peoples of the Middle East, inherited their stonework techniques from a common predecessor civilization? A civilization so ancient that it left no direct records, only scattered remnants of its technology adopted and adapted by later cultures. This idea brings us to the issue of dating ancient sites. Mainstream archaeology places the construction of Puma Punku around 500 to 600 AD, based largely on radiocarbon dating of organic materials found at the site. However, radiocarbon dating measures when organic matter died, not when the stones were cut. If later cultures occupied a site built by an earlier one, the radiocarbon dates would reflect the later occupation, not the original construction. Some researchers have proposed that Puma Punku is much older than conventional timelines suggest. Arthur Poznański, an Austrian engineer who studied the site extensively in the early 20th century, believed that astronomical alignments at Tiwanaku indicated a construction date around 1500 BC. Though his methodology has been criticized, his conclusion has never been definitively disproven. Other researchers have observed signs of water erosion consistent with exposure to heavy rainfall, a phenomenon that hasn't occurred in the region during the current geological epoch. If true, this would push the age of the site back to a time when the climate was dramatically different, perhaps around the end of the last ice age, approximately 12,000 years ago. The catastrophic destruction at Puma Punku itself may offer clues for dating. Something tremendously violent happened here. The massive stones are scattered, as though thrown by an explosion or a flood of biblical proportions. Some stones appear displaced hundreds of feet from their original positions, while others are shattered, broken by forces that should not have affected structures built to such exacting standards. Mainstream explanations attribute this destruction to earthquakes, possibly accompanied by seismic liquefaction or flooding from Lake Titicaca. These natural causes are plausible, but some researchers believe the destruction may have been far more dramatic. A hypothesis that has gained traction in recent years is the Younger Dryas impact theory, which proposes that a comet or asteroid struck Earth approximately 12,800 years ago, causing mass extinctions and climate chaos at the end of the Ice Age. If Puma Punku predates this event, its destruction may be tied to the same cataclysm that reshaped the Earth's environment. Imagine this scenario. A sophisticated civilization flourishes in the Andean highlands during the late Ice Age, possessing advanced stonework, standardized manufacturing processes, and knowledge of metallurgy and engineering that rivals or exceeds anything achieved millennia afterward. Then catastrophe strikes. An impact event triggers earthquakes, floods, and climate collapse. The civilization is destroyed, its population scattered, and its knowledge fragmented. Survivors of this catastrophe carry what they can remember to distant lands, where they become the mysterious figures remembered in mythology, the gods who came from the sky, the civilizers who taught agriculture, astronomy, and architecture, the bearded strangers who appeared after the flood and started the world anew. Over millennia, new cultures arise in the ruins. The Kilka, then the Tiwanaku, then the Inca. They find the ancient stones already in place, already cut with precision beyond their capabilities. They worship at sites they did not build, telling stories of gods and giants who moved mountains in the time before time, leaving behind their own artifacts and radiocarbon signatures, which future archaeologists mistake for evidence of original construction. This hypothesis, though speculative, aligns with existing evidence in ways that the conventional narrative doesn't. It helps explain why the precision at Puma Punku exceeds what the Tiwanaku could achieve. It explains why similar construction techniques appear at sites separated by oceans and millennia, and why so many ancient cultures share similar flood myths and civilizing tales. It ties together seemingly disparate strands of human history, suggesting a lost civilization's influence across the globe. The andesite blocks of Pumapunku stand as silent witnesses to this lost knowledge. Their surfaces remain smooth and their angles true. Even after 1,500 years of exposure, their tight interior corners defy the tools and techniques that the Tiwanaku are supposed to have used. The H blocks, with their interlocking geometries, represent a level of precision machining that contradicts everything we are told about the capabilities of ancient civilizations, whether they were carved, cast, or even vitrified. These blocks tell us of a sophisticated manufacturing process that has eluded modern technology for centuries. The vitrification of stones found at Sacsayhuaman, also in Peru and other sites, only adds to the mystery. The surface of these stones has been transformed into a glassy finish that suggests they were exposed to extreme heat temperatures far beyond what any conventional construction technique could generate. Vitrified stones challenge our understanding of how ancient civilizations worked with materials, and suggest that they possessed knowledge and technologies that we have yet to fully comprehend. This question, how ancient civilizations achieved such feats, extends beyond Pumapunku, reaching across the globe to other ancient sites where granite was drilled with precision that defies the supposed primitive tools. From Giza to Sacsayhuaman, evidence of lost technologies appears at every turn, challenging the official narrative of slow and steady human progress. These stones whisper to us of advanced methods, machine-like precision, and standardized manufacturing capabilities that could not have been achieved through brute force and primitive tools alone. As we explore these ancient sites and their impossible constructions, we must ask, what did our ancestors know that we have forgotten? What knowledge has been lost to time? And what does it tell us about the peaks of civilization that may have come before recorded history? The answers, hidden in the stones and embedded in the precise cuts and grooves, may force us to reconsider everything we thought we knew about the progress of humanity. At Sacsayhuaman, certain stones scattered throughout the fortress complex exhibit surfaces that seem more like glass than stone. This is not a mystical claim, it's a matter of verifiable science. When silicate-based rocks are exposed to temperatures above 1,100 degrees Celsius, their surface melts, and if the cooling process is rapid, the molten surface solidifies into a vitrified finish, similar to the transformation of sand into glass. The vitrification found at Sacsayhuaman is on a scale that defies conventional explanation, presenting a challenge to any typical geological process. Vitrification is known to occur at ancient sites across the globe. Hill forts in Scotland and ancient structures in Turkey exhibit similar traits. But Sacsayhuaman stands out due to its scale. The temperatures needed to cause this process would require immense heat, far beyond what ancient Andean civilizations were believed to have been capable of producing. Modern industrial furnaces can easily reach these temperatures through controlled combustion or electrical heating. However, ancient metallurgists could only achieve temperatures sufficient to smelt copper or bronze, which max out at about 1,000 degrees Celsius. In small, insulated crucibles, an entirely different task than heating multi-ton blocks to over 1,100 degrees Celsius and applying this heat evenly across their surfaces. Yet, the vitrified surfaces of Sacsayhuaman gleam in the Andean sunlight, their glass-like finish distinct from the rough, unworked stone nearby. So how did they come to be? One possible explanation is natural lightning strikes. Lightning can reach temperatures of 30 degrees Celsius along its narrow channel, more than hot enough to vitrify stone. If lightning had repeatedly struck specific locations at Sacsayhuaman, it might have created the vitrified effects observed. However, lightning strikes leave distinctive patterns, typically fulgurites or branching scars radiating from the point of impact. The vitrified surfaces at Sacsayhuaman do not fit this profile. They are too uniform, too extensive, and too integrated into the worked stone surfaces to align with natural lightning effects. Another theory involves ancient warfare. Some researchers speculate that prehistoric conflicts may have involved weapons capable of generating extreme heat, similar to modern incendiary devices or even directed energy weapons. While this idea feels more speculative and ventures into science fiction territory, it could explain both the vitrification and the catastrophic destruction seen at sites like Pumapunku. Ancient texts from India describe astral weapons capable of unleashing devastating heat and light, capable of destroying armies and cities in a single blast. Could these ancient myths be preserving memories of technological weapons used in a forgotten age? A more grounded explanation revisits the stone softening theory we discussed earlier. If the ancient builders of Sacsayhuaman possessed a chemical process to make stone malleable, the vitrification might have been a byproduct of that technique, rather than evidence of external heat. Some chemical reactions produce localized heating or fundamentally alter the crystalline structure of materials, potentially transforming them into a glass-like surface. There is intriguing circumstantial support for this theory. Colonel Percy Fawcett, the British explorer who vanished in the Amazon in 1925 while searching for a lost city, recorded stories from indigenous peoples about a plant whose juices could dissolve rock. Fawcett himself claimed to have observed birds using a similar botanical agent to excavate nesting cavities in solid rock. Although Fawcett's samples were lost, the idea of stone softening has gained some contemporary attention. More recently, researchers have observed birds in the Andes that appear to soften rock using a mixture of plant material and saliva. If true, this natural phenomenon could explain how ancient civilizations might have softened and shaped stone with minimal effort. Peter de Jong and Christopher Jordan, researchers who have studied ancient Peruvian construction, propose a more exotic hypothesis. They suggest that vitrified surfaces at sites like Sacsayhuaman were created intentionally using high technology. Their analysis of stone samples shows signs of heating sufficient to vitrify the stone. Accompanied by unusual mineral formations, they speculate that an ancient civilization possessed the ability to soften, shape, and re-harden stone at will, leaving the vitrified surfaces as a signature of their lost technology. However, this hypothesis raises many questions. What was the heat source? How was it controlled? Why would such a civilization leave no trace of its technology? The vitrified surfaces at Sacsayhuaman are not uniformly distributed. Some stones exhibit the characteristic glassy finish, while adjacent stones show no signs of heating. This selective vitrification complicates any simple explanation involving uncontrolled natural events, as it suggests controlled application of heat rather than random lightning or fire. Interestingly, the vitrified stones are not all located where one might expect intentional processing. Some are found on exterior surfaces exposed to the elements, while others are on interior faces, hidden once the construction was complete. If vitrification was part of the construction process, we might expect to see it primarily on working surfaces, joints, or faces that needed shaping. The seemingly random distribution of vitrified areas suggests multiple causes over time, perhaps original construction processes at some points, and subsequent natural events such as lightning, fire, or even unknown occurrences later on. The mystery of Sacsayhuaman deepens with its vitrified stones, leaving us with more questions than answers. Was it a lost technology, or an ancient process we don't understand? Could it be a combination of methods known and unknown used by the ancient builders to achieve what seems impossible? What remains undeniable is that Sacsayhuaman stands as a testament to a civilization that left us riddles wrapped in stone, challenging our assumptions and urging us to look deeper into the mysteries of the past. The unfinished obelisk in the granite quarries of Aswan in southern Egypt is one of the most intriguing and perplexing artifacts in the field of ancient engineering. Located in the blistering heat of the Nile Valley, where the river winds its way through ancient stone, the obelisk represents an unfinished project, a monumental work abandoned before its completion. It was meant to be the largest single piece of stone ever worked by ancient hands. Standing around 42 meters tall and weighing nearly 1,200 tons. For context, this would have made it far larger than the Statue of Liberty, which stands at 46 meters from base to torch, and would have dwarfed the largest stones at Stonehenge, which weigh about 50 tons. The unfinished obelisk was partially carved from the living bedrock and remains connected to the quarry by one side and its base. The reason it was abandoned is clear. A crack appeared during the extraction process, making it unfit for use. But its very incompleteness has revealed some fascinating insights about ancient engineering, particularly regarding the methods and capabilities of the ancient Egyptians. Despite its unfinished status, the obelisk offers significant clues that completed monuments, now hidden in plain sight, may be concealing. It speaks to the immense scale of ancient engineering projects and the astonishing precision they achieved. How did ancient builders work with materials so hard that even modern technology finds them challenging? How were they able to extract and transport stones so massive? This unfinished obelisk is one of the few pieces of evidence showing the cutting-edge techniques employed by the ancient Egyptians. It's as if this unfinished project was a testament to their capabilities, frozen in time before its potential was fully realized. The size and scale alone challenge everything we have been taught about the technology available at the time to lift and carve such a stone, especially with the precision required for the monumental constructions like the Great Pyramid or Sacsayhuaman, would require techniques far beyond what conventional archaeology has suggested for ancient Egypt. The methods used to quarry and carve these immense stones remain a subject of great speculation. The unfinished obelisk also raises profound questions about the technological limits of the time. While many explanations assume the use of copper chisels, sand, and abrasives, this would not explain the remarkable precision observed in the cut stone, nor would it account for how such immense blocks were extracted and transported without the advanced machinery we have today. Some researchers have even pointed out that this incomplete obelisk reveals a crucial missing piece in our understanding of ancient Egyptian craftsmanship. While modern technology can cut through granite using industrial machinery with diamond-tipped tools, the ancient Egyptians apparently achieved results that are not just similar, but in some cases, even more precise. Some argue that vitrification, an extreme heat process causing rock to melt and then solidify into glass, may have been used in ancient stonework, possibly in combination with methods that have been lost to time. As we look at the unfinished obelisk and other monumental stoneworks around the world, it becomes increasingly apparent that ancient civilizations possessed knowledge and techniques that we are only just beginning to understand. Whether they were able to manipulate heat, use specialized tools, or even utilize technologies we have yet to discover, the evidence scattered across the globe points toward a sophistication we can scarcely comprehend. The unfinished obelisk stands as a stark reminder of how much remains hidden in the deep past. With its huge size, immense weight, and precise engineering, it may very well be a clue to the lost techniques of an ancient civilization capable of feats beyond our own technological understanding. It not only challenges our assumptions about ancient engineering, but also fuels the ongoing debate about the lost technologies of the past, forcing us to re-examine the true extent of human achievement throughout history. And so, like the mysterious vitrified stones of Sacsayhuaman, the unfinished obelisk begs the question, how much have we truly forgotten? What technologies were lost in the aftermath of catastrophes or the passage of time, and are we ready to rediscover the secrets of the ancients? These stones speak, but their message is unclear. What remains certain is that they demand to be understood, and in understanding them, we might unlock a forgotten chapter of history that could change everything we know about human civilization. The unfinished obelisk at Aswan presents an enigma that is more than just a forgotten stone left in a quarry. It's a symbol of something greater, something that challenges the basic assumptions we have about ancient Egyptian technology and methods. As we examine the marks on the surface of this massive granite block, we are confronted with the idea that the techniques used here may have been far beyond what conventional archaeology allows. The traditional explanation posits that the Egyptians used dolerite pounders to break away the granite. An arduous, slow process of pounding the stone with hard tools. While this theory is supported by evidence of dolerite tools found at other sites and depictions of workers engaged in similar tasks, when we observe the unfinished obelisk closely, something doesn't add up. The surface of the stone shows smooth, curved depressions, not the rough, jagged surfaces one would expect from a tool that repeatedly struck the stone. The marks appear as if the stone was cut with controlled, continuous strokes, not pounded into submission. What tool could achieve such precision on one of the hardest stones known to man? Christopher Dunn, a manufacturing engineer, has pointed out that these marks are inconsistent with pounding or chiseling techniques. The patterns suggest that the tool used to carve the stone was likely not a simple copper saw or a thermal spooling technique. Instead, Dunn has proposed that the ancient Egyptians may have had access to a type of machinery we have yet to identify. This possibility, though dismissed by mainstream Egyptology, remains unsettling. How could a civilization, using what we understand as simple tools and human labor, achieve such extraordinary results? The mystery deepens when we consider the logistics of quarrying and removing such a massive block. The obelisk lies in a narrow trench, with walls rising several meters on either side, limiting the space in which workers could maneuver. The sheer volume of material that would have to be removed to free the 1,200-ton obelisk raises another question. Hundreds of cubic meters of granite would need to be pulverized. But archaeologists have found only a fraction of that material. Where did the rest go? Was it systematically removed and transported? Or was the process of extraction far less wasteful than we would expect from such an intensive method? If the unfinished obelisk had been successfully extracted, it would have faced an even more monumental challenge: transportation. How could the ancient Egyptians have moved such a massive stone from Aswan to its intended destination some 200 kilometers north, possibly to Cairo? Modern engineers have debated the feasibility of moving such a weight using ancient technology. Some have suggested floating the obelisk on multiple barges along the Nile, using the river's natural buoyancy to support its weight. Others argue that it would have been dragged along the riverbank on sledges for shorter distances. But no matter the method, transporting a 1,200-ton monolith would be a feat of incredible difficulty. While ancient Egyptians were indeed able to quarry, transport, and erect obelisks weighing hundreds of tons, the unfinished obelisk pushes the limits of what we thought possible for their time. The engineering required to extract, move, and erect this colossal monument would demand not only advanced knowledge, but also an understanding of forces and materials that may have been lost to time. We may never know exactly how the Egyptians achieved these feats, but the evidence scattered across quarries, temples, and monuments points to a level of sophistication that modern technologies still struggle to replicate. As we examine these unanswered questions, the unfinished obelisk remains a silent testament to an ancient world that may have known more than we have credited them for. Whether its construction techniques were based on forgotten knowledge, advanced technologies, or methodologies we haven't yet discovered, the mystery it presents continues to challenge our understanding of ancient Egypt and the capabilities of past civilizations. The Latan obelisk, now standing proudly in Rome, originated from Karnak and weighs a massive 450 tons. Similarly, multiple other obelisks, each exceeding 200 tons, were transported from the quarries of Aswan to various sites throughout Egypt. Whatever methods the Egyptians used to move these colossal stones, they certainly worked, and the scale of their engineering efforts continues to challenge the capabilities of modern construction, leaving the quarries behind. Let's travel to the north, to Giza, where the famous Great Pyramid looms on the plateau. Step inside the Great Pyramid through a passage originally cut by Caliph al-Mamun's workers in the 9th century AD. As you navigate the cramped ascending passage and duck through the Grand Gallery, You eventually reach the king's chamber, where an extraordinary object awaits one that connects directly to the mysteries we've been exploring. The king's chamber coffer is a rectangular box made from a single block of rose granite, the same material as the unfinished obelisk. Though not particularly large by Egyptian standards, roughly the size of a modern bathtub, its precision is nothing short of extraordinary. When Sir William Petrie measured the coffer in the 1,880 seconds, he found that its interior surfaces were flat to within 1/100th of an inch. The corners were square to tolerances that modern machinists would admire, but the real mystery lies in how it was made. Petrie found evidence of spiral grooves on the coffer's interior surfaces, marking it as drilled using tube drills. These overlapping drill holes are identical to those found on core 7 inches, the Petrie Museum, drilled with a feed rate that far exceeds what would be possible with simple tools. This evidence challenges the standard explanation of how such precise work could have been done with copper tools and sand abrasives. But there's another anomaly: the coffer is slightly too large to fit through the narrow passages leading to the king's chamber, implying it was placed in the chamber before the pyramid was completed. This raises another critical question. What was the purpose of the coffer? Mainstream Egyptology asserts that the coffer was a sarcophagus intended for Pharaoh Khufu, yet no mummy was ever found inside. And there's no grave evidence, no inscriptions, no burial goods, no canopic jars. Christopher Dunn, in his book, The Giza Power Plant, presents an alternative theory that the Great Pyramid was not a tomb, but a machine designed to generate and transmit energy. In this model, the coffer would have acted as a resonating component, tuned to specific frequencies and filled with substances that generated hydrogen gas. The extreme precision of the coffer's construction would be crucial to its function, ensuring it could operate at optimal frequencies. This theory, though speculative, addresses aspects of the coffer's design that the tomb hypothesis cannot. The precise flatness of the coffer, the drilled hollowing technique. Why would a simple burial chamber need such extraordinary engineering? In Saqqara, the questions continue to multiply. We've already examined the massive granite boxes, weighing 70 to 100 tons, finished to tolerances that defy conventional methods. These boxes are carved from rose granite and black basalt, both extremely hard materials. Their precision, smooth surfaces, and perfectly square corners challenge the idea that they were simply made with copper tools. When Auguste Mariette opened the boxes in the 1,850 seconds using explosives because the 30-ton lids were too heavy to lift otherwise, he found them empty. No mummified bulls, no inscriptions, nothing at all. The mainstream explanation claims that these boxes were sarcophagi for the sacred Apis bulls, living embodiments of the god Ptah. When an Apis bull died, it was supposedly mummified and interred with ceremony. Yet these boxes, carved with astonishing precision, were never used for that purpose. The precision of these boxes raises more questions than answers. Mummified bulls don't require surfaces flat to 10,000 ths of an inch, nor do burial practices demand such exacting standards. Perhaps these boxes were not sarcophagi at all. Perhaps they were used for something entirely different in an earlier context, a time and culture long before the dynastic Egyptians. Maybe they were repurposed, with later generations seeking to assign them a religious role they didn't originally hold. The hieroglyphic inscriptions added later are crude, scratched into the boxes after their precise surfaces had already been completed. This may suggest the dynastic Egyptians found these objects already in place and simply adopted them, reinterpreting them for their own rituals. This idea ties into a broader hypothesis that a lost civilization, one with advanced engineering and manufacturing techniques, left behind these artifacts, only to be forgotten by time. The evidence seems to point backward toward a civilization that existed long before recorded history, one whose knowledge was passed down in fragments, leaving clues for us to uncover. From Core 7, with its impossible drill marks, to the King's Chamber coffer with its precision surfaces, to the Serapeum boxes with their optical flatness. Each artifact reveals a pattern of technology that mainstream archaeology is hesitant to explain. The unfinished obelisk, still stuck in the quarry with its scoop marks, further supports this growing picture of ancient Egypt. These stones, meticulously carved, drilled, and shaped with techniques that defy the use of copper tools and bronze implements, are left behind as silent witnesses to a forgotten technological age, one that may have been more advanced than we realize. The stones, it seems, hold the answers to questions we have yet to fully ask. They are waiting, in their precision and their perfection, for us to recognize the capabilities of the past that still elude us today. The mysteries are there, scattered across Egypt and around the world, and the more we look, the more we see a pattern of lost knowledge and forgotten technologies that may one day help us rewrite history itself. Across the globe, ancient structures exhibit remarkable acoustical properties, hinting at a forgotten knowledge, one that might have involved using sound as a force to manipulate physical matter. The ancient legends speak of trumpets, horns, and chants used to control the very fabric of nature. Myths tell of stones floating through the air, guided not by human hands but by invisible forces, influenced by the rhythms of sound that could move mountains. For centuries, these tales were dismissed by rationalist scholars as mere superstition, the product of primitive minds struggling to explain phenomena beyond their understanding. But now, in modern laboratories around the world, a quiet revolution is unfolding. Researchers are discovering that sound may hold far more power than previously imagined. Let's return, for a final time, to Puma Punku, the mysterious site in the Bolivian Altiplano. When the Spanish conquistadors arrived in South America and questioned the locals about the construction of these awe-inspiring megaliths, they were met with baffling explanations. The indigenous people spoke of trumpets used to move the stones. They claimed the first builders were not mere mortals but divine beings, capable of making stones levitate through the power of sound. The Inca, who ruled the region when the Spanish arrived, denied having built Puma Punku. They maintained that the site had been constructed in a single night by gods from an ancient time, long before human memory. The Spanish, finding these answers absurd, dismissed them as mythology, the imagination of a primitive people struggling to understand the mysteries around them. But what if these myths, these stories passed down through generations, contained a fragment of truth? What if the construction of Puma Punku really did involve sound in a way we've only just begun to understand? Acoustic levitation, the ability to suspend objects in mid-air using sound, is no longer science fiction. It's a demonstrable reality. When sound waves of sufficient intensity and frequency interact, they create pressure nodes in the air, points where the waves cancel each other out. Objects placed at these nodes experience a reduction in effective gravity, enabling them to float. Acoustic levitation has been studied for decades, but the technology has made dramatic advancements in recent years. In 2016, a team of researchers from the United Kingdom and Brazil successfully levitated a 50mm polystyrene ball using sound waves, overcoming earlier limitations on the size of objects that could be manipulated with sound. By 2017, scientists at the University of Bristol had developed techniques that not only levitated objects, but also allowed them to be manipulated and moved along controlled paths using arrays of ultrasonic speakers. In December of 2025, physicists at the Institute of Science and Technology Austria achieved another major breakthrough by combining sound waves with electrostatic charge, allowing multiple objects to be levitated simultaneously without collapsing. These developments are expanding the possibilities of acoustic levitation far beyond anything previously thought possible. And it's clear that our ability to manipulate matter with sound is growing rapidly. But the question that continues to haunt researchers in alternative history is this: could ancient civilizations have understood and used these principles long before us? Consider the Great Pyramid of Giza, For instance, it resonates at specific frequencies, amplifying sounds generated within its chambers to extraordinary levels. The ancient Hippodium of Malta, a subterranean temple complex dating back over 5,000 years, was designed with acoustics in mind, creating a reverberation that can almost be felt physically. In Peru, the Temple of Chavin de Huantar housed massive conch shell trumpets, tuned to generate sound waves capable of physically disorienting those who stood inside. These are not mere coincidences. The evidence is mounting that the ancient world may have understood the manipulation of sound in ways we are only now rediscovering. Could the builders of Pumapunku have employed acoustic levitation to move the massive stones into place, using sound waves as a form of energy? Could the construction of ancient megalithic sites, from the Great Pyramid to Chavin de Huantar, have involved technologies based on sound manipulation, technologies that were lost, or perhaps deliberately hidden, after a great catastrophe? As we delve deeper into the mysteries of these ancient sites, we must consider the possibility that the technologies we are uncovering today were not entirely new. Perhaps they were rediscoveries of knowledge, long lost to time. The stones at Pumapunku, the pyramid, and other ancient sites may hold secrets that challenge our understanding of human history and technology. Secrets hidden in plain sight, waiting for us to look closely and listen carefully to what they have to say. The evidence is compelling, and the more we study it, the more we find connections, threads that tie distant cultures and long-forgotten civilizations together. Whether or not ancient people used sound to defy gravity and manipulate the physical world, one thing is clear: the past may be more advanced than we ever realized. The ancient builders of the world, it seems, understood acoustics on a sophisticated level, manipulating sound in ways we are only just beginning to comprehend. From the construction of massive megaliths to the legends of floating stones, ancient cultures spoke of sound as a powerful force, one that could control matter itself. Could sound have been used to levitate massive stones? The physics behind this is certainly complex, but not entirely beyond the realm of possibility. To levitate a 100-ton stone using sound alone would require vast acoustic power far beyond what human voices or simple instruments could generate today. The energy required would be enormous, and the precision needed to control sound frequencies so precisely would be extraordinary. A disruption in the standing wave pattern would cause the stone to fall catastrophically. But imagine a civilization capable of meeting these challenges, a society with the understanding of resonance, using advanced sound equipment to levitate stones, just as the legends describe. The Pumapunku site in Bolivia might offer some evidence supporting this theory. The blocks there lie scattered across the landscape, as though displaced by an explosion, but with no crater and no obvious signs of explosive force. What if this destruction was the result of a catastrophic failure in acoustic levitation technology? A sudden collapse in the standing wave patterns used to keep the stones suspended in air could release an immense amount of kinetic energy, causing the blocks to scatter. This theory remains speculative, but it aligns with the physics involved. Across ancient cultures, we find remarkably consistent stories about the use of sound to move objects. In Egypt, the 10th century historian al-Masudi described how the pyramids were built with sound. Workers would place magical papyrus beneath stones, strike them with a metal rod, and watch as they floated through the air, moving along a designated pathway. The specificity of his account, including mentions of metal rods and metal poles, suggests there may have been more to the process than simple superstition. Could this be an ancient form of acoustic levitation? In Tibet, the legend of monks levitating stones with drums and trumpets provides another striking parallel. The stones were lifted up a cliff face, using carefully placed instruments that created specific acoustic patterns. Although attempts to verify this account have been inconclusive, it fits into a larger global pattern of sound-related construction techniques. A modern mystery that mirrors these ancient legends is the Coral Castle in Florida, built by a single man, Edward Leedskalnin, between 1000 1923, and 1951. The stone structures weigh up to 30 tons. Lead Skalnin, who worked alone and at night, never revealed how he moved these enormous stones. He claimed to have discovered the same secrets used by the ancient Egyptians to construct the pyramids, hinting at a combination of magnetic and harmonic principles. While no definitive explanation exists, some believe he may have used acoustic or electromagnetic levitation. What ties all of these accounts together is the central role of sound, whether it's vibration, harmonic resonance, or acoustic levitation as the mechanism used to move massive stones. These legends, present across Egypt, Tibet, and the Americas, may not just be fantasies, but rather fragmented memories of a long-lost technology. Could ancient builders have discovered and utilized sound in ways that allowed them to manipulate the very material world? In modern physics, we have begun to explore acoustic levitation as a viable technology. In 2016, a team of researchers levitated a polystyrene ball 50 millimeters in diameter, much larger than previously thought possible. Since then, advancements in the field have allowed scientists to manipulate objects in 3 dimensions using ultrasonic speakers. Electromagnetic and gravitational manipulation theories are also being explored, with physicists pushing the boundaries of what sound and vibration can achieve. The question remains, could ancient civilizations have possessed this knowledge? The evidence of Puma Punku's scattered stones, Giza's acoustically resonant Great Pyramid, and the Chavin de Huantar temple in Peru all point to a deeper understanding of sound, vibration, and levitation technologies we have only just begun to rediscover. Perhaps, one day, we will truly understand the extent of ancient technological knowledge. The legends of floating stones may not be as fantastical as we once thought. The trumpets may sound again, and the stones may rise. Until that day, we can only wonder, listening for the echoes of a vanished age. As you stand on the heights of Sakai Huaman, gazing down at the ancient city of Cusco below, the sprawling rooftops and colonial churches might seem to blend seamlessly with the modern life of the Inca Empire's former capital. However, from a higher vantage point, another story unfolds, a design that has intrigued researchers for centuries. Cusco, when viewed from above, forms the unmistakable silhouette of a puma. This design is not mere coincidence or the result of human imagination. The puma shape is deeply embedded in the history of the city, appearing in colonial chronicles and verified by modern archaeological surveys. The Inca purposefully designed their capital to reflect the majestic cat, with Sakai Huaman at the puma's head. This geometric symbolism wasn't just artistic, it was cosmological. The puma represented the Kipacha, the earthly realm, the world of the living, while the condor symbolized the upper world of the gods, or Hananacha, and the serpent embodied the lower world, or Ukupa. These 3 creatures formed a cosmic trinity, with the puma asserting the Inca's mastery over the earthly realm. The very layout of Cusco itself, designed in the form of a puma, was a proclamation of this control. But the questions about Cusco's design don't stop at its shape. To plan a city in such an intricate, animal-shaped form requires advanced knowledge of surveying, spatial planning, and execution across vast areas. The Inca were certainly capable of such sophistication, with their complex road systems and architectural feats. However, some researchers argue that the puma-shaped city predated the Inca by centuries, suggesting that they inherited this remarkable design from an earlier civilization. If this is true, it would push the origins of Cusco's distinctive layout back far earlier than conventional archaeology allows, possibly even into pre-Inca periods. The fortress of Sakai Huaman, the most prominent structure in Cusco and the heart of the puma's head, holds the key to this mystery. If it wasn't built by the Inca, then the city layout itself must predate their rise. The polygonal walls, the precision fitting of stones, and vitrified surfaces at Sacsayhuaman all suggest advanced techniques capabilities beyond what the Inca were credited with. The evidence here challenges conventional ideas and hints at lost technologies. Sacsayhuaman, a fortress designed for defense, with zigzag walls that served as barriers against invasion, suggests a strategic and military purpose. Yet, it also housed towers, temples, and ceremonial spaces, suggesting that its role extended far beyond warfare. The Muyok Maka, a large circular tower, likely had astronomical or religious significance, playing a central role in Inca ceremonies, such as the Inti Raymi, the Festival of the Sun. The Spanish chroniclers, upon discovering the site, spoke of the treasures and ornaments that once adorned the area, many of which were stripped during the conquest. Today, the remains of the fortress stand as a testament to a lost civilization's architectural prowess. The modern Russian geophysical team that explored Sacsayhuaman in 2012 uncovered anomalies that defy conventional explanations. Their use of advanced equipment, such as ground-penetrating radar and magnetometers, revealed strange magnetic properties in certain stones and subsurface structures that suggested hidden chambers. The composition of some stones didn't match local materials, raising questions about their origin. These findings point toward construction techniques far more advanced than simple carving and placement. The intricate ways the stones were joined, their contact surfaces, and the stress distribution across the walls suggest methods unknown to mainstream archaeology. The stones of Sacsayhuaman are not just a mystery of design but a puzzle of origins. From the puma-shaped layout of Cusco to the precision stonework of the fortress, the evidence increasingly suggests that the Inca inherited a profound legacy from an earlier, more advanced civilization. A civilization that understood not only architectural design, but also the manipulation of materials, possibly through unknown techniques that have been lost to time. Sacsayhuaman stands as a silent witness to this forgotten age, challenging us to question the narrative of progress and uncover the truths buried beneath its massive stones. The Russian researchers, though cautious in their conclusions, contributed significantly to the growing body of evidence, suggesting that Sacsayhuaman is older and more enigmatic than conventional archaeology. Acknowledges their findings, combined with Spanish chronicles, reveal further complexities in the narrative of the Inca and their predecessors. Several Spanish sources claim that when the Inca conquered the Cusco region in the 15th century, they found Sacsayhuaman already standing. According to these accounts, the fortress was ancient, built by a vanished people whose identity was unknown even to the Inca. The Inca, it is said, merely restored and modified the existing structures, incorporating them into their own mythology. If this is true, it places the original construction of the megalithic walls in a period long before the rise of the Inca Empire, before the Quilca culture, and into a time that modern history has forgotten. The polygonal stones, precise fittings, and possible vitrification at Sacsayhuaman all point to a civilization with capabilities far beyond what the Inca were known to possess. This theory fits into a broader pattern noticed throughout the Andes. Many sites show a discontinuity in construction phases, where lower levels of megalithic stonework display remarkable precision and mystery, while upper courses of simpler construction are clearly Incan. It seems the Inca inherited the foundations laid by earlier civilizations and expanded upon them, adding their own structures but maintaining the precision of the original builders. One of the most striking examples of this is Tambo, located in the Sacred Valley of Peru. Here, massive blocks of red sandstone were transported from a quarry on the opposite side of a valley, across a river, and up a steep mountainside. These blocks were then fitted into walls with the same precision seen at Sacsayhuaman. The Inca claimed to have built Tambo, but the megalithic sections at the site display techniques that differ significantly from typical Incan construction. This suggests either that the Inca possessed specialized skills used at certain sites, or that they inherited these methods from earlier cultures with different capabilities. Alternative history researchers, such as Graham Hancock, propose a theory that these earlier builders represent a lost civilization, one that flourished before the end of the last ice age and was destroyed by cataclysms around 12,800 years ago. According to this hypothesis, survivors of this civilization spread across the world, bringing fragments of their advanced knowledge to the indigenous peoples they encountered. In South America, these survivors were the civilizers remembered in mythology, the gods who taught agriculture, astronomy, and architecture. The Inca may have inherited the knowledge and techniques of these lost builders, incorporating them into their own culture and mythologies. One prominent figure in Inca mythology is Viracha, the creator god who emerged from Lake Titicaca, described as tall, bearded, and light-skinned features that do not match the indigenous Andean population. Viracha traveled across the land, teaching the arts of civilization before departing across the Pacific Ocean, promising to return one day. This story may preserve memories of contact with an unknown civilization, bringing advanced knowledge and technology that elevated local cultures to new heights. The fortress at Sacsayhuaman and the puma-shaped city of Cusco could be the legacy of these visitors. Their stonework, representing the techniques of a civilization from a vanished world. This interpretation, though speculative, fits the evidence of advanced stoneworking techniques and vitrification found at various sites. Both in the Andes and across the world, the stones of Sacsayhuaman stand as silent witnesses to a lost civilization, their precision and longevity challenging the assumptions of mainstream archaeology. Thousands of tourists visit Sacsayhuaman every year, marveling at the zigzag walls, climbing over the massive stones, and listening to guides explain that the Inca built the fortress using nothing but copper tools and human determination. But the stones themselves tell a different story. Their precise fitting and the lack of tool marks suggest a level of craftsmanship far beyond what was supposed to be possible at the time. As you examine the stones where they meet, where their surfaces join with flawless precision, consider the complexity of fitting 12 angles on a single block face. Each angle carved to match its neighbors in 3 dimensions, an achievement that would challenge even modern engineering with the tools the Inca supposedly had. Does the official story really explain what we see? The puma still guards its secrets, watching over Cusco, its enigmatic presence undisturbed for centuries or millennia. The questions raised by Sacsayhuaman do not stop at the Andes. They stretch across oceans and continents, connecting to similar mysteries in ancient Egypt, Puma Punku, and other distant lands. The global pattern of precision stonework, whether through polygonal masonry, advanced drilling techniques, or inexplicable vitrification, suggests that ancient civilizations shared a knowledge and expertise that we cannot yet fully comprehend. These patterns, spread across the globe, demand a global explanation. We've seen how ancient sites from Sacsayhuaman in Peru to the quarries of Aswan in Egypt exhibit the same mysterious precision in their stonework. The techniques used to create these remarkable structures seem to defy the capabilities of the cultures traditionally credited with their construction. The precise, mortarless fitting of stones at Pumapunku and the vitrified surfaces at Sacsayhuaman suggest that advanced technologies, possibly even lost to history, may have been at work. As we journey through these ancient wonders, we're faced with a challenge to recognize the patterns emerging from the evidence, to question the assumptions of mainstream archaeology, and to consider the possibility that the world's ancient civilizations were far more connected and technologically advanced than we have been led to believe. The mystery of these megalithic marvels beckons us to explore deeper, to look beyond the conventional explanations, and to open our minds to the incredible potential of what our ancestors may have achieved. The global distribution of precision stonework adds another layer to the mystery. connecting seemingly unconnected cultures through a shared architectural technique, from Sakai-Huaman in Peru to Edo period fortifications in Japan to Mycenae in Greece, and the Hittite capital of Hattusa. We find the same polygonal masonry. The stones, cut with multiple angles and fitted together with extraordinary precision, appear in regions separated by vast distances and millennia. The consistency of these patterns raises the question of whether this technique was independently invented by different cultures or passed down from a common, forgotten source. Polygonal masonry, a technique where irregular stones are precisely fitted together without mortar, appears in ancient sites across South America, Europe, Asia, and even Oceania, from Easter Island to Lebanon and Turkey. Similar construction methods are evident, with huge stones quarried, transported, and assembled with extreme precision. This raises the possibility of either independent invention or a shared technological legacy passed between cultures long before written history began. In places like Puma Punku and Sakai-Huaman, the precision of the masonry exceeds what was thought possible with the tools available at the time, particularly when we consider the use of metal clamps to hold stones together. This technique, seen in Puma Punku, Delphi in Greece, and Angkor Wat in Cambodia, is evidence of advanced technological knowledge. The use of molten metal poured into stone recesses to bond stones shows consistency in design and technique, suggesting a standardization that might point to a shared source or template. The mysteries of these ancient stones and the global pattern they create tie into larger cosmic phenomena, notably the precession of the Earth's axis. The number 72, the number of years it takes for Earth to precess by 1 degree, appears in ancient myths, architecture, and cosmology. This number is found in cultures around the world, such as in Egyptian, Hindu, and Norse traditions, as well as encoded in the dimensions of the Great Pyramid of Giza, which also reveals a deep understanding of astronomy and mathematics that challenges the conventional timeline of ancient civilizations. While some critics argue that these connections are coincidental, the physical evidence of impossible precision, such as drill cores with unrealistic feed rates, granite boxes with optical flatness, and polygonal walls with hairline joints, cannot be dismissed. These artifacts defy the conventional explanations, which suggest that all ancient stonework was achieved through manual labor and simple tools. While patience and craftsmanship can explain some remarkable feats, the scientific principles behind the precision stonework at these sites do not align with the tools that should have been available at the time. Could it be that advanced technology existed in ancient times, a lost form of knowledge that was somehow forgotten, buried, or destroyed? The global distribution of these precision techniques suggests that the capabilities required to achieve such stonework were not localized, but rather part of a shared heritage among ancient civilizations. This raises the hypothesis that a civilization with such knowledge existed long before recorded history, possibly even before the Younger Dryas impact, an event that is believed to have caused a global cataclysm approximately 800 years ago. The impact, which is thought to have resulted in climate shifts, floods, and fires, might have led to the collapse of this civilization, scattering its survivors, who then passed on fragments of their knowledge to later cultures. This idea, known as the lost civilization hypothesis, proposes that the Inca, Egyptians, and other ancient peoples inherited knowledge from a sophisticated civilization that existed before the Ice Age, leaving only the remnants of their technology in the form of mysterious stonework scattered around the globe. From the stones at Sakai-Huaman to the unfinished obelisk at Aswan to the granite boxes at Saqqara, the evidence points to something beyond conventional understanding. The precision involved in these structures, whether through cutting, fitting, or transportation, cannot be explained solely by the available tools of the time. The inability to replicate these feats today using ancient techniques suggests that knowledge, The stones at Pumapunku, Sakai-Huaman, and Giza tell a story of advanced knowledge, a lost civilization, and the legacy that has endured for millennia. These remnants cut from the hardest stones on Earth, shaped with impossible precision, and placed together with techniques that defy explanation, carry a message to us, one that transcends the boundaries of time. In Pumapunku, we find andesite, harder than steel, shaped with precision that modern technology can scarcely replicate. Drilled holes spiral like threads of a screw. The H-blocks, with their uniform dimensions and impossibly tight corners, reveal a craftsmanship that speaks of tools and techniques long lost to history. Yet, something catastrophic happened here. Something destroyed these structures, scattering massive stones like debris in a storm. The clues left behind are cryptic, hinting at a civilization capable of feats we struggle to comprehend, yet wiped out by an event so violent that the city's remains were scattered far and wide. In the mountains above Cusco, Sakai-Huaman stands as an eternal witness to the secrets of the ancient world. The zigzag walls, formed from stones so precisely fitted together that even time cannot wear them down, seem to speak of a knowledge beyond its time. Vitrified surfaces, evidence of heat that should not exist in an age of bronze and stone, stand as silent testaments to lost technologies. The puma that watches over the ancient city below symbolizes mastery over the earthly realm, but the exact methods used to create such precision remain a mystery. The Spanish may have dismantled everything they could move, but the foundation stones, too massive and too perfectly joined, remain as if to say, "We were here." In Egypt, beneath the sands and amidst the monumental structures that have captivated the human imagination for centuries, we find the same evidence of impossible precision. Granite boxes with tolerances so fine they rival modern aerospace engineering. Unfinished obelisks marked with scoop-like depressions that no known tool could have made. And drill cores with feed rates that exceed modern technology. All point to a past civilization capable of feats we cannot replicate today. The Great Pyramid, with its encoded mathematical constants and alignment to true north, raises further questions. How could a civilization without the tools and knowledge we possess today have achieved such precision? What did they know that we have forgotten across 3 continents? At Pumapunku, Sakai-Huaman, and Giza, we see a pattern emerge, the same precision stonework, the same techniques, the same impossibilities that defy the logic of conventional archaeology. The precision is undeniable. The evidence is real. Yet, the answers remain elusive. What knowledge did these civilizations inherit or discover that allowed them to create structures that still stand? Defying time and the forces that should have brought them down, we have considered many possible explanations. Patient craftsmanship, pushed beyond all reasonable expectations. Lost technologies that were once in the hands of civilizations that no longer exist. And even theories like geopolymer casting, stone softening, and acoustic levitation. Each theory accounts for some aspects of the evidence but fails to explain everything. The mystery persists, stubborn and irreducible. Perhaps that is the point. Perhaps these stones, carved with precision and joined with expertise, were meant to endure because they carry a message that must not be lost. Stone endures where other materials do not. It resists time, weather, and the elements, surviving far beyond the lives of those who built it. If a civilization knew that its end was near, if it saw destruction coming and understood that everything it had built would be lost, how would it communicate with future generations? Paper burns, wood rots, metal corrodes. Even the most durable materials eventually return to the earth. But stone endures. If it is cut precisely enough, joined tightly enough, and made from the hardest materials available, the message might survive. These ancient structures are not just remnants of a forgotten past. They are silent witnesses to a lost knowledge, a message written in the precision of stone, waiting for us to understand, to listen. The stones remember what we have forgotten, and perhaps, someday, they will speak their secrets again. This closing segment of the exploration brings us full circle, reinforcing the idea that precision itself is the key message these ancient stones convey. Their sheer perfection, crafted with techniques that defy conventional explanation, challenges our modern understanding and highlights the potential for human ingenuity. While the names of the builders, the dates of construction, and the true purposes of these monuments may remain lost to time, the evidence of capability remains. The stones, in their timeless silence, stand as a testament to what once was, and what could be again. The idea that progress is not linear, that civilizations can rise, fall, and rise again is a profound reflection. We often assume that the technological advancements of today are the pinnacle of human achievement. But these ancient sites suggest otherwise. The precision stonework and engineering feats visible at Pumapunku, Sakai Huaman, and Giza are not the products of primitive craftsmanship. They are monuments to possibility, demonstrating the incredible potential of human, or perhaps pre-human knowledge and skill. The challenge before us is not to fear the past, but to embrace the possibilities it presents. What lost technologies, forgotten techniques, or hidden knowledge might we still rediscover? Perhaps we are on the cusp of reclaiming the potential of our ancestors and surpassing the limits we believe are imposed on us today. The mysteries of these ancient monuments are not just puzzles to solve, they are invitations to expand our own capabilities, to think beyond the limits we have placed on human achievement. As we move forward, the stones remain, silent and enduring, guarding their secrets. They remind us that the path of progress is not always a straight line, and that the most profound discoveries often lie hidden beneath the surface, waiting for the right moment to be uncovered. The stones remember, and now, we too are part of that story. Good night, and let us continue to wonder, question, and seek understanding in the face of these ancient enigmas.